Hello everyone, I am Shrikant Zade, Assistant Professor, Department of Computer Science and Engineering, Priyadarshini Institute of Engineering and Technology, Nagpur. Our today's topic is cache memory. Learning outcomes. At the end of the lecture, students will be able to understand the concept of the cache memory. And second one, students will be able to understand the cache coherence problem. In the last 2 or 3 lectures, we studied regarding the memories. So, I will ask one questions. What are the different type of the memory used in computers? You have a 10 second. Take out your notebook and write down the answer. Okay, we will continue. Cache memory concepts. We very well know the processor is very faster than the memory device. So that the processor is ideal most of the times due to the lack of the instructions coming from the memory. To overcome this obstacle, there is a concept of the cache memory, because this obstacle is due to the speed of the main memory cannot be increased beyond a certain points. So that there is a concept of the cache memory in between the main memory and the processor. The cache memory is an architecture arrangements which make the main memory appear faster to the processor than it is really is. This main cache memory is smaller than the main memory and having the higher speed. Cache memory is based upon the property of the computer program or the principle known as a locality of reference. The locality of reference analysis of the programs indicate that when instruction is a localized area of a program are executed repeatedly during some period of time, while the others are accessed relatively less frequently. That principle is called locality of reference. There are two types of the locality of reference. One is a temporal locality of reference and second one spatial locality of reference. In temporal locality of reference, the instructions that can be executed frequently, such as if we take the example of the for loop, while loop or do while loop. In loop, if we take the for loop for I equal to 1 to 100, then that particular block that can be executed 100 of the times, means that particular area of the memory can be accessed again and again and again, means that is the locality of the that is the temporal locality of the reference. Whereas in spatial locality of reference, the instructions that are executed with the address that is close to the recently instructions are likely to be executed. Next, the concept of the cache memory. As we have seen in the diagrams, the processor, the cache memory and the main memory. The cache memory is in between the main memory and the processor, and as compared to the size of the main memory, the cache memory is small. The processor issues the read request a block of the word is transferred from main memory to the cache memory one word at a time. Processor always requests or it can generate the addresses to read the data or to write the data from the main memory through the cache. Subsequent references to the data and its block of the word are found in the cache memory. At any given time, only some block in the main memory are held in the cache. This is due to the size of the cache memory is small as compared to the size of the main memory. Let us example, the main memory is of having the 1 megabyte size, whereas the cache memory is having the 256 kilobyte. So that there are the, if we take the example, there are the 4 block 256, 256, 256, 256. Okay. Which block in the main memory are in the cache is determined by a mapping function or the placement policy. So due to this size, which block of the main memory can be placed into the cache memory and where have to be placed, that can be done by the policy that is called a placement policy or the mapping functions. There are 3 types of the mapping function or the placement policy, that are direct mapping, associative mapping and set associative mapping. We will see in detail in the coming lecture all the mapping with numericals. When the cache is full and the block of the word need to be transferred from main memory, some block of the word in the cache must be replaced. This is determined by the replacement policy. No doubt, the size of the cache is a 256 kilobyte, whereas the size of the main memory is a 1 megabyte. So it is not possible to occupy the 1 mega memory in the 256 K. So that when one by one, when the cache is full and any request is generated and we have to copy from the main memory to the cache memory, then we have to replace some block of the cache memory and send to the main memory. So which block have to be replaced can be decided by the policy that is called the replacement policy. Cache hit. Existence of the cache is transferred to the processor. The processor issues the read or and the write request in the same manner. If the data is in the cache, it is called a read or the write hit. Means whenever processor want the data, it can issue the read signal and that data is available into the cache memory. So that data is given to the processor frequently. That is called a read hit. The data is obtained from the cache. Whereas write hit, cache has a replica of the content of the main memory. Content of the cache and the main memory may be updated simultaneously. This is the write through protocol or the write through policy. Whenever have the processor want to write the data, so it can write into the cache memory and at the same time into the main memory. The content of that particular block can be updated simultaneously. This policy is called a write through policy. Whereas update the content of the cache and mark it is updated by setting a bit known as a dirty bit or a modified bit. The content of the main memory are updated when this block is replaced. This is called the write back or the copy back protocols. In this write back or a copy back, we can change the content of the block of the main memory after sometimes when it is required. But Initially, we can change the content of the cache memory immediately. Cache means if the data is not present in the cache, then read miss or write miss occurs. Read miss. A block of the word containing this requested word is transferred from the memory. After the block is transferred, the desired word is forwarded to the processor. The desired word may also be forwarded to the processor as soon as it is transferred without waiting for the entire block to be transferred. This is called a load through or the early restart. So basically, when the read request is generated from the processor, it is no doubt it is a one word, but the memory can copy from main memory to the cache memory in terms of the block with word by word by word. When processor generates some address and that address is not found into the cache memory, read miss is occur. It can copy the data from the main memory to the cache memory. When that particular word is came to the cache memory, immediately it is transferred to the processor without waiting for the all block have to be transferred from the main memory to the cache memory. Write miss. Write through protocol is used, then the content of the main memory are updated directly. If write back protocol is used, the block containing the address word is first brought into the cache. The desired word is overwritten with new information. Cache coherence problem. This is one of the important problem in the cache. A bit called as a valid bit is provided for each block. If the block contains the valid data, then the bit is set to 1, else it is set to 0. Valid bit are set to 0 when the power is just on. Means there is a nothing in the cache memory. Initially, when we boot the system, cache memory is reset to 0. It is blank. When a block is loaded one by one from main memory to the cache memory for the first time, the valid bit of that particular block is set to 1. Data transfer between the main memory and the disk occur directly bypassing the cache. When the data on the disk change, the main memory block is also updated. Means we are bypass the cache memory and writing the data to the main memory and the disk at the same time. But that particular block of the cache memory is not updated at that time. However, if the data is resident into the cache memory, then the valid bit is set to 0. What happens if the data in the disk and the main memory change and the write back protocol being used? In this case, the data in the cache may also have changed and is indicated by the dirty bit. The copy of the data in the cache and the main memory are different. This is called cache coherence problems. One option is to force a write back before the main memory is updated from the disk. So there is a questions. What